We set up our data product before we even went in the field, and we created a pipeline that includes our field protocol. And here we have the checklist that we set up. And also in our input folder, we set up some folders to hold our downloads. We also have the data logger program on the data logger that we deployed and a folder for any field notes that we collected. Well, let's say now we have deployed a data logger and we've also gone out and retrieved it. And therefore we have downloaded the data into the downloads folder. And we've done it twice over the course of the summer of 2021, spring and summer of 2021. And here we have a data logger that was deployed on March 4th of 2021 and one that was deployed on July 13th of 2021. So now we can start working on the code that allows us to pull the data from these data logger files into R and start working with it to create our data product. I'm going to go back to the protocol folder. We've already set up a pipeline and we have an RStudio project file to let us get started in the right working directory. And I can just double check. Recall that we've got a .r profile file that has the command setwd with the 2 dots saying that we want to go to the parent directory of the working directory. And that means our working directory is going to be the root of the pipeline called par deployment rather than the protocol folder. That means all our code has to consider that this is our working directory and all our paths need to be relative to this directory for them to work. And we've got started on an R Markdown file with a par deployment section. And we talked about a couple of different ways to include some information in our report about when the report was last compiled. So that's what this code chunk here is at the end. Now we're going to need a new code chunk. So we need 3 backwards apostrophe, an R in curly brackets, 3 more backwards apostrophes to indicate the end of the code chunk. And this code chunk is going to have code that reads the table from the input folder where our downloads are located. So I'm just going to call the first table that I read in table, and I'm going to assign that to what comes back from the function read.table. I can do a help on read.table. And some of the important arguments we're going to need are the file that we want to read from, whether we're reading in headers, what the separator is for the different columns. Read table is for reading in 2-dimensional data in a tabular format, hence the name read.table. So things like header tells you what are the headers of each column in the table, what is the character that separates the data for each column of the table, and we'll see how that works as we work through this example. Now I know this is going to need some quite a few pretty long arguments, so I'm just going to go ahead and break this line of code into multiple lines. And the first thing I need is the file. I need to give it the file argument that tells me where is the file I'm reading the data from. In the pipeline, the file is going to be in the 1 underscore input folder. I can put a // to start typing a path, and I'm going to hit the tab. We've done this before, and you can see, well, this is a little confusing because we see processing.r, processing.rmd, desktop.ini. These are all things that are here in our protocol directory. So in this case, RStudio knows how R Markdown works. And in this case, it's thinking that the code that's in these chunks is going to be run as protocol as the working directory. And that's just an artifact of it being the default. The default place when you use R Markdown for the working directory is going to be wherever the RMD file is. But our working directory should be 1 level up. Now you can change RStudio's configuration to put it in the correct working directory. And you can do that with this little arrow button next to the knit. This knit button is part of the R Markdown capacities of RStudio. And if I click on this little arrow, it gives me some options for how to use knit. And you're going to see this option called knit directory. And you're going to see that the default is the document directory. And that's because if you don't change R Markdown's render, it's going to consider the init directory being wherever the RMD file is, which in our case is the protocol folder. So in this case, we want it to be our working directory, and you have that option right here. Our current working directory, which we've already established here, is the root of the pipeline. And if we changed the configuration for RStudio for the init directory to be the current working directory, that should fix this issue with where our working directory is, where our relative paths are, to be relative to the working directory. So same idea, if I put a / and hit tab, now you can see I'm in a different folder. I am in a folder that has the input protocol and incremental, and that's because I'm now using the init directory as this root of our pipeline. And that's where I want it to be, because that's how I have R Markdown set up to deal with all of the code in the R Markdown file. So I can select input, and then I need to go to that downloads folder because that's where I put the folders I downloaded from the data logger. Hit tab again, and I have two files here, one deployed on March 4th of 2021 and one deployed on July 13th of 2021. Let's just read the first of these from March 4th. And now I have my relative path relative to my working directory, the root of the pipeline. I'm going to go to the input folder of the pipeline, then this data logger download subfolder of the input folder, and finally the file name that I want to read is this .csv file. Now, whenever you're reading in a CSV file, it's helpful to understand what the structure of that CSV file is. And I can just use my RStudio interface here to go to this downloads folder. And I can open this folder directly in a text editor in RStudio by going to View File, by clicking on the file name and going to View File in RStudio. Now, this happens to be a bigger file. It shouldn't be a problem for my computer, but it's warning me that it could take some time to process. But that's okay. I'm just going to go ahead and open it because I know my computer should handle it just fine. Now you can see what's in this text file. And a CSV file is just a text file, but the CSV part means that the text for different columns in a table are delimited with commas. So CSV stands for comma delimited. For a comma delimited text file. And you can see the commas here. This first row is actually all general information. In this case, there's commas here, but these don't correspond to the columns in the table. This is just general information about the deployment. For example, this is the serial number of the data logger. This is the model number of the data logger. This is right here, the program that it's running. And this is table 1 from the data logger. Then we get into the things that are specific to the columns of the data in the table. And in the second column is where we find the headers for the columns in the table. So the first column is the timestamp. The second column are the records. The third column is the voltage differential that it measured. And then we have this temperature of the panel. That's the temperature of the data logger panel. Not the temperature of the transducer, but the temperature of the data loggers panel. And then here is the par flux average, specifying that we have an average value of par flux over some period of time. And you can see these make sense. These are timestamps. You can see it's a date time in quotes. So that means it's a string, character string representation of a date and time. There is a record number. This is just a counter for the number of records in the table. This is the voltage that it's measuring. This is the panel temperature, 25.82 in degrees Celsius. And this is the par flux. And that's in micromoles of photons per second per second. Micromoles of photons per square meter per second. Finally, we have some more metadata about each column in the next two rows. This row is telling us something about the units. These are just metadata. The program doesn't actually know anything about the numbers, but it can pass on metadata that you put into the program. So if you put units for each of your variables in your data logger program, they will show up in the table here. That's just a good way to keep track. And here, as you can see, micromoles per square meter per second for the units on the par. And finally, this row just tells you something about whether the data are averaged or not. So here, this third column, this voltage, we're just sampling. This is just telling us what the voltage is instantaneously at the end of each time period that it's measuring. And we can tell that it's measuring every 5 minutes based on the timestamp. Here's 2220, 2225. So this data logger is set up to measure every 5 minutes. So this is just a sample of whatever the voltage is at the end of each 5-minute period. Here it says average. That means that this panel temperature and this par is actually the average of those values taken every 5 minutes. So it's the average of the values over the past 5 minutes. So it's important to look at these to make sure the context of time of these, because these voltages are not necessarily going to line up exactly with the par fluxes, because the voltages are just a sample of the voltage, and the par fluxes are the average over each 5-minute period. So that's just a rundown on what this data looks like, and we need to know about the structure of these data to know how we want to read it in and configure this. So going back to our call to read table to read in these data, I've told it which file I want to read in, which is the file we're looking at. The next thing that's important is to tell read table what is the characters that separate each column in the data. So read table, because it's called read table, is assuming the data is in a tabular format, and you have to tell it what separates the column is in the table. This is a CSV file, so the separator are all of these commas. So if I put a comma in quotes, that will tell it the comma character is what separates columns. In this case, our data table has more than one row before you actually get to the data. So we need to tell it to skip some number of rows before it starts reading in data, because these, especially this first row, are not appropriate to read as something that indicates what's in each column. This is just general metadata about the run as a whole. So if I just want to read in the tabular data, I have to tell R to skip 4 rows. So we've got 4 rows, 1, 2, 3, 4, of things that are other than data. In fact, they're metadata. Now we're going to get back to how we read in the metadata later, or define the metadata later. But for now, let's just read in the table of data so we can get a feel for what we're dealing with. Finally, we have to tell it that we don't want it to consider any of the data that we're reading in part of the header. So if we go back to the help for read table, you'll see there's this header argument right here. It's false by default, so technically we don't have to set that to false. But just to be sure someone reading our code knows that we're not reading in the header, I'm just going to go ahead and specify that argument as well. So those should be the basics that we need for reading in a table. And now we can start testing our code. So we're in our studio. Ultimately, we've talked about how this code is going to be run as it's compiling the R Markdown document. But in this case, we want to make sure our code's working. And RStudio makes it easy to do that in several different ways. First of all, if we want to run all the code in a chunk, and right now we only have one line of code in this chunk, we can use this arrow button on the chunk. On a Windows PC, there's a hotkey for that. You can hold down Control-Shift-Enter, and that will run all the code in a chunk as well. I think there's a hotkey on Mac too, but I can't remember if it's Command or Control-Shift-Enter, but it's something like that. So if I hit this Run button for the chunk, it will run all the code in this chunk. Now, just to illustrate how RStudio needs to know the right path for the working directory, to give to NIT to use, I'm going to show you what happens if I set this back to document directory. So I'm going to change the settings for RStudio to document directory. which means the working directory is going to be wherever the R markdown is, which is going to be in the protocol directory in this case. And you can see now if I hit this run directory, I'll actually get a warning or an error saying that it can't open the connection. Can't find this file, can't open the connection, it can't read the table. There's a red line here saying there was an error. So this is how you get started with troubleshooting an R Markdown and writing the code yourself that's in the R Markdown and making sure it's doing what you expect. So again, this is why you have to have this init directory set to current working directory if you have your current working directory somewhere other than this protocol directory. If I run it again, now it shows up as green, and I should have a table data structure. We can quickly look at what this table looks like by just clicking on it. That runs a view with a capital V of table, and we can see we have a tabular format data structure. And we've got the 5 different columns that are here in terms of the time step, record, vdiff, our temperature of our panel, and our power flux. And we have 5 columns in our table. It's called these V1, V2, V3, V4, V5 for now. I think the V stand for value. And then we have our date time stamps for date time. We have our record numbers. We have our differential voltage on our power sensor. We have our panel temperature. And we have our power flux measurement. So this gives us a data structure. Let's look a little bit at what that data structure is. If I do a type of on that data structure, it's going to tell me that it's a list. Now we're going to get a little bit more into object-oriented programming here and talk a little bit about what objects in R represent. In this case, everything in R is an object of some kind. Type of is the type underlying the object, but if you want to know what type of object it is or what class of object it is, you can use the class function. So I'm going to do a class on table. We can see this is a data type called a data frame. So this is getting us into a more complex type of data structure. In this case, it's a 2-dimensional data structures. We've been talking mostly about 1-dimensional data structures so far, but now we're talking about 2-dimensional data structures. And the way a data frame works is it's a list of vectors where the vectors each represent a column. So each one of these columns is a vector. And we have a list of vectors where each element of the list represents a different column in this 2-dimensional data structure. So this is going to give us the basis for starting to talk about object-oriented programming in R and talking about more complex 2-dimensional data structures of data.